capacity of piles. What is the load carrying capacity? The maximum load a pile can bear without sinking or settling into the soil. Um, um, Before sinking, how much load it can take, that is called the load bearing capacity, or we can call the ultimate bearing resistance, or we can call it as allowable, sorry, ultimate load carrying capacity of the pile, the maximum load a pile can take. And when you, that is the maximum load a pile can take is ultimate load, but we always design a pile for allowable load or safe load. Now what is safe load? Just divide the ultimate load by factor of safety, we will get another term that is called allowable load, and we use that for the design purposes. And it is determined by yeah, by using these methods we can find the ultimate load and just divide by factor of safety to get the allowable load, or we can find the maximum settlement, and for that settlement we can find the allowable load, or we can go for overall stability of the pile foundation. And the maximum settlement allowed for a pile foundation in Indian standards is 12 mm. Only 12 mm is allowed for pile foundation. Okay. Why these concepts and formulas are important is they have asked the methods and the formulas for 13 mark question. All the 7 methods, 4 for single pile and 3 for group pile capacity. They asked the 7 methods formulas alone one time for 13 mark question. So you should learn all the formulas. Okay, single pile load carrying capacity. First we will start. As I said, for a single pile we have 4 methods. One is dynamic formula, second is static formula, third is pile load test, and fourth is penetration test. First we will see the dynamic formula. Dynamic formula na, we consider the soil to be a dynamic system. We consider the formula to be a dynamic system, or we consider the soil uh, to uh, as we know the pile, when we are driving the pile inside the soil is subjected to vibrations. We take into account those vibrations, and we take into account the effect of the hammer, we take into account the effect of driving into the formulas of the load carrying capacity of the pile. So we consider the soil to be a effective dynamic system. So this soil is mostly used for sandy soils because the permeability is very high there. Also pore water pressure is very low. Since the permeability is high, pore water pressure is low. So we go use this formula for sandy soils. The assumption for the dynamic formula is the kinetic energy is equal to work done by the pile. We use physics or the basic principles here for finding the load carrying capacity. Instead of using soil properties, we use or foundation properties, we use the work done values of the hammer also. So kinetic energy is equal to work done is the formula here used. And dynamic formula there are two types of formula. One is engineering news formula, that is one of the oldest dynamic formula. Then the revised formula is Hiley's formula. So we have two formulas in dynamic formula itself. One is ENR formula, engineering news formula, and another formula is Hiley's formula. So engineering news formula, ENF, because this formula was first published in a journal magazine. It was first published in a magazine called Engineering News Magazine. So it is called Engineering News Formula. Uh, it is published in the year 1888, and the ultimate load is given by QU. As I said, no, here we will worry about the load. ultimate load. So QU is equal to WH eta H divided by S plus C. We'll see one by one what is what. W is weight of the hammer in kilonewton. H is height of fall. Hammer is risen and put down to drive the piles inside the soil. So the height of fall of the when you do the impact test, no, you will raise the hammer for 75 centimeter and then drop it. Similarly, what is the height of fall here? Then we have eta h. Eta nale efficiency, you know that in hydraulics lella you put eta for efficiency. So eta h is efficiency of the pile hammer. S is penetration, pile penetration per blow, or we simply tell it is set. S stands for set. Set na the last blows which we give for the last setting of the pile inside the soil. Final set of blows that we give, that is called uh, yes. Okay, it is measured in centimeter. For then C is a constant. It varies depending upon the type of hammer. Yesterday I said hammer is classified into many types. When we use diesel engine, no, we for running the hammer we call it as diesel hammer. When we use steam pressure to rise and fall the hammer, then we call it a single acting or double acting hammer. If the weight of the hammer is below 10,000 kg, it is going to be a single acting hammer. If it is more than 10,000 kg, it is going to be double acting hammer. And then take drop hammer. Drop hammer is like lifting and dropping off in the gravity. And this is called the constant we use for drop hammer is 2.54 centimeter, and for steam hammer it is 0.25 centimeter. So you substitute everything there in the QU formula, we will get um, the ultimate load capacity of the pile based on ENR formula. This is a dynamic formula. Now weight into H, we can replace the term WH by energy. You know that energy is equal to weight into H. Weight into H. So energy term we can replace. So the formula can also be QU is equal to EH eta H by S plus C, where E is equal to WH. E suffix H and eta suffix H divided by S plus C. Okay, and the efficiency of the hammer is also constant, and it also varies depending upon the type of the hammer. You have to memorize these values. So a single acting hammer, the efficiency is from 0.7 to 0.9. For a double acting hammer, it is from 0.75 and uh, uh, 2.85. For diesel hammer it is from 0.8 to 90, which means it is from 80 percentage to 90 percentage, like that. And now if you want to find allowable load, what should we do? Allowable or safe load is equal to ultimate load by factor of safety. So we find the ultimate load and we divide by factor of safety. When coming to engineering news formula, we always use a factor of safety 6. 6, very high factor of safety is used for engineering news formula. Next formula is Hiley's formula. So you please note down these formulas alone. EH eta H by S plus C, where EH is equal to W into H. Okay, Hiley's formula. Some of the modifications of the engineering news formula led up to another formula in 1925 to 1930, and that formula is given by QU is equal to WH eta H eta B divided by S plus C by 2. There we used eta H alone. Here we multiply eta B. What is eta B? We'll see it. Where eta H B is the efficiency of the hammer blow. Eta H is efficiency of the hammer and eta B is efficiency of the hammer blow. The blowing given by the hammer. So H is the height of fall, S is the set, and you'll see. So and here one is there in engineering use formula C is a constant. See we saw there. Then here C is going to be in engineering use formula C is going to be a constant 2.54 or 0.254 centimeter. Whereas in Hiley's formula, C is not constant. We find C using the one formula. C is going to be, it's a constant, but it depends upon the, it is the sum of compression of the pile, that is C1, then compression of dolly packing. Dolly packing அப்படின்னா between yesterday I said between the pile, when you are driving the pile into the soil, we should protect the head of the pile as well as the toe of the pile. For bottom of the pile to be protected, we use pile shoes, and we have pile at the head of the pile, at the top, to protect the top of the pile from the direct effects of the hammer blow. We will have a dolly in between. Dolly is something bigger than the bigger diameter than the pile, and it is placed in between the pile and the hammer. So the hammer blows will be falling on the dolly, and the dolly will be protecting the pile while driving the pile. So that is dolly. So C is given as C1 plus C2 plus C3, where C1 is the compression of the pile due to compression of the pile. Second, C2 is compression of the dolly. C3 is due to the compression of the ground. So that is what C1, C2, and they have separate formulas. When you take C1, it is due to C1 is due to dolly, and it is equal to 1.77 R by A. If we use dolly, it is 1.77 R by A. If if without dolly, we use this formula, C1 is equal to 1.77 R by A. With the dolly, we use the formula 9.05 R by A. Then C2, it is due to the compression of the pile while driving, and it is given by the formula 0.675 RD by A. I'll tell what is R. RD by A. Then C3 is given by, C3 is compression of the ground while driving the pile, and that is given by the formula 3.55 R by A. 3.55 R by A. Here R D. The C2 ல வந்து பார்த்தீங்கன்னா we have the formula 0.657 R D by A. Here D is the length of the pile. D is not diameter of the pile. D stands for length of the pile here in this formula. Then R we have, A is cross sectional area of the pile. If the pile cross section is square, then area is B square. If the pile is circular, then the cross sectional area is pi by 4 d square, diameter square. So we have this area of the pile as A. Then we have R. R is nothing but frictional pile resistance. In some places we can R is equal to Q, load, resistance. R is equal to resistance Q.
the load given. So R can be equal to QU also. Ultimate load, no, we can substitute pile resistance. Okay, so this is the C. Then we have formula for eta B. Eta H is constant, and for drop hammer, this. So in this is the main formula. This is the main formula. We are seeing the terms. W is the weight of the hammer, height is the height of fall, and eta h is also constant. See, if now we saw some formulas. Eta b, when you take eta b, whenever Hiley's formula is asked, no, we should always find a term called, whenever Hiley's formula is asked, we should first of all check whether uh, check for a value. The weight of the pile is greater than EP, or weight of the pile is less than EP. We should always check whether, whenever we have to solve a Hiley's formula, weight of the pile is greater than EP or less than EP. If the weight of the pile is greater than EP, then we have eta B formula as this. If it is less than EP, we have another formula for eta B. Eta B is efficiency of the hammer blow. And what is E? Coefficient of restitution. When you have learned in engineering mechanics, you might have learned the restitution force. Force of the loss of restitution. When two balls are there, steel balls are there, and when they come and collide with each other, there will be some restitutional force, and the coefficient of restitution will be useful there. So coefficient of restitution is given by E, small letter E, and the capital P is the weight of the pile plus weight of the anvil plus weight of the helmet. The anvil, helmet, dolly, all these are protective elements between the hammer and the pile. So this total weight is given as capital P. Weight of the pile, weight of the anvil, weight of the helmet. They are all total weight is given as P. Only the weight of the pile is taken as W. Now eta B. If W is greater than EP, E is constant. I will give you the values of E. Coefficient of restitution values. So we use the formula W plus E square P by W plus P. If it is less than EP, we use the formula. The first formula is same as the above formula. W plus E square P by 1 W plus P minus W minus EP divided by W plus P the whole square. And E is coefficient of restitution, and it is given by from values 0.0 to 0.5. If you are going to use a steel rammer while driving a RCC pile, and if you are going to use a cast iron rammer, then when we use the value 0.4. If using a steel rammer, we use 0 to 0.5. For a cast iron rammer, we use E is equal to 0.4. And if you are driving a um, pile cap with wood above the RCC pile, then we use coefficient of restitution as 0.25. So when wood comes into picture, the coefficient of restitution reduces. E is equal to 0.25. So note down these formulas. W greater than EP, now we use eta B formula. This one, W plus E square P by W plus P. And if it is less than EP, we use the formula eta B is equal to W plus E square P by P. W plus P minus W minus EP divided by W plus P the whole square, where W is the weight of the pile, E is the coefficient of restitution depending upon the type of the hammer used, and capital P is the total weight of the pile and the materials involved with the pile. And when we calculate this eta b and we all finally substitute, also we calculate the c1 c2 c3 and add it and find the value of c, and finding the c value and eta b, we substitute everything in this formula to get the ultimate load. And we have uh, in engineering news formula, ENR formula, we have for factor of safety as 6. I said we should take a factor of safety 6 for ENR formula. For Hiley's formula, it is recommended to use the value of 4. 4 is used. Factor of safety 4 is used for Hiley's formula. Factor of safety of 6 is used for ENR formula. So remember this, we are going to solve a problem with this problems. Only one time simple problem was asked. Otherwise இதுல இருந்து ரொம்ப questions வந்ததில்ல. But gate questionsல I have seen lot of questions from this ENR formula and Hiley's formula. So for gate exams this is very important. For this I have repeatedly asked in all competitive exams. I have seen this questions, dynamic formulas. Otherwise உங்கள் யூனிவர்சிட்டி கொஸ்டின்ஸ்க்குலாம் இது வரைக்கும் கேட்டதில்லை. It has not been asked. Okay, first you'll see the question. A precast concrete pile 35 centimeter by 35 centimeters. So the pile is a square pile. 35 centimeter by 35 centimeter, driven by a single acting steam hammer. So it is going to be a single acting hammer. Estimate the allowable load. So what is allowable load? Ultimate load by factor of safety. So we find the ultimate loads first by using engineering news formula. Use factor of safety 6 and Hiley's formula factor of safety as 4. Use the following data. Maximum energy is equal to 3500 kilonewton centimeter. Weight of the hammer is equal to 35 kilonewton. Length of the pile is equal to 25 meter. Efficiency of the hammer is equal to 0.8. Coefficient of restitution is equal to 0.5. Weight of the pile cap is equal to 3 kilonewton. Number of blows for last 25.4 mm is equal to 6. Modulus of elasticity of the concrete is equal to 2 into 10 power 7 kilonewton per meter square. Assume any other data required. Okay. Efficiency of the hammer, coefficient of restitution are all given in the question itself. Okay, so we will solve the problems. First, we should find the engineering news formula, ENR formula. What is the formula? Q is equal to EH eta H by S plus C. What is E? Energy. Energy கொடுத்திருக்காங்களா questionல? It is given. First given data is energy. How much? 3500. And eta H. What is eta H? Efficiency of hammer. It is given in the question as 0.8. Then S. S is set per blow. Yeah, how much centimeter there is a penetration and how many blows it is given. And it is in the given data, 7th point is number of blows for last 25.4 mm is equal to 6. அப்படின்னா செட் கண்டுபிடிக்கணும் அப்படின்னா we will just divide 25.4 divided by 6. That will give you the set value. Set value is how much penetration it has been done, 25.4 divided by number of blows, how much it was given, by 6. So 25.4 by 6, uh, 25.4 by 6 mm. Now convert into centimeter. 2.54 divided by 6 centimeter. Okay, this is set, which is 0.42 centimeter. We are converting into 0.42 centimeter set value. Then C. C is an C is going to be constant, and it is a, since our hammer is single acting steam hammer, we assume the value C is equal to 0.254. Now substitute everything in QU formula. We get 3500 into zero point 0.8 divided by 0.42 divided plus 0.254. That value will be 4133.9 kilonewton. This is QU. Actually questionல என்ன கேட்டிருக்காங்க, allowable load has been asked. What should we do? We should divide by factor of safety. For ENR formula, factor of safety of 6 is considered. So just divide 4133 by 0.9 divided by 6, factor of safety. That will give you 689 kilonewton. 689 kilonewton. This is ENR. ENR is very simple, but when you have Hiley's formula, no, it is not so simple. Why? Eta B anga varudhu, hammer blow. We know the formula is Q is equal to WH eta B eta H by S plus C by 2. And what is W into H? Energy. WH is energy. So now first you'll find uh, energy no போடலாம், or we can find weight separately also. Weight of the pile, yeah, first you'll find weight of the pile. What is the weight of the pile? Weight of the pile is not given in the question, so we should find the weight of the pile. We know that density is equal to mass by volume, or density is equal to weight by volume. And from that formula, what is weight? Weight is equal to density into volume. That is what it is written here. Weight of the pile is equal to volume of the pile into density of the pile material, or the density of the pile na density of the pile material. Pile material is concrete, so we are going to use the density of concrete. And what is volume? Area into length. Area into length. So weight is equal to area into length into density. Now area of the pile. For finding area of the pile, okay, size of the pile was given in the question. Given data illa na first na vaasthen question la. When you see the question, no, you can see the weight, size of the pile. See, precast concrete pile 35 centimeter by 35 centimeter. So the size of the pile is 35 by 30. Cross sectional area is going to be 35 into 30. So that is 35 into 30 centimeter. Now we have to substitute in meters. So multiply 0.35 into 0.35 into what is density of the concrete? Density of the concrete is equal to 24. So we are multiplying 24. And what is the length of the pile? 25 meter. So area is 0.35 into 0.35 into length of the pile is 25 meter given in the question, into density of the concrete is 24 kilonewton per meter cube. So when you multiply everything, you will get 73.5 kilonewton. Density of concrete is 24 kilonewton per meter cube. That is, should be memorized. Now we should find the total weight of the pile. How to find the total weight of the pile? Total weight of the pile plus any other weight given in the question. Pile related. What is given in the question? In the sixth point, it is given weight of pile cap is equal to 3 meter. If weight of dolly is given, weight of anvil is given, you have to add those also. Okay, so total weight of the pile, capital P is equal to W plus weight of the pile cap. So weight of the pile is 73.5, just now we found out, plus weight of the pile cap given in the question 3 kilonewton, that will give you 76.5 kilonewton. Okay, so weight of the pile is found. Now to find eta b, we have two formulas, two possible formulas. W less than EP, W greater than EP. So here EP is, what is coefficient of restitution? 0.5 E into capital P, just now you found out 76.5 kilonewton. So EP is equal to 0.5 into 76.5, that is equal to 38.2 kilonewton. Now W is how much? 73.5, and EP is how much? 38.2. So EP is less than the value of W. So we use the second formula. Eta B is equal to W plus E square P by plus W plus P minus of W plus EP, W minus EP divided by W plus P the whole square. And if you see, the denominator is same for these two things. Left side also W plus P, the right side of the formula W plus P. ஸ்கொயரில் வேரியேஷன்ஸ் இருக்குது, and remember the sign conventions also in the formula. Now you substitute the values. W is 35. I'm sorry, I made a mistake here. There is a mistake inside this formula. What is W? W is going to be, it seems I cannot correct it here. Okay, W is equal to 35 ன்னு substitute பண்ணியிருக்கேன், but it's wrong. No, W is 76.5. Okay, very sorry for the mistake. W is here, what do you find W as? Sorry, I didn't notice it. Okay, W is 73.5. That should be substituted here. I'm sorry for 35 substituted in this formula. It's not 35, it is 73.5. So 73.5 plus 0.5 square, 76.5. Substitute the values, but the answer is correct, 0.476. This is already in the question, already in the book actually, so answer is correct. Took the answers from the book itself. Okay, then we have to find the constant value. We know that C equal to C1 plus C2 plus C3. You have to write the three formulas. You have to memorize the three formulas. 9.05 R by A plus 0.657 R D by A plus 3.55 R by A. Substitute R. What is R? Resistance. It is not given in the question, but you can take, as I said earlier while explaining the concept, you can take the resistance R as total load QU. Total load QU. So R is kept as QU, and we don't know the value of R, but we know the value of A. What is A? Area 0.35 into 0.35, so square pile. So substituting those values, you'll get the constant C is equal to 0.022 into Q. And what is D in this formula? D is the length of the pile. Length of the pile is given as 25 meter. So substituting that, we get C is equal to 0.022 Q. After finding C and after finding eta B, substitute everything here in this formula. And what is WH? WH is energy. How much is the energy? 3500. So substitute that, 3500 into eta B is given in the, just now we found out 0.456 and 476. And what is eta H? Efficiency of the hammer, which is 0.8 given in the question, divided by S is set 22 2.54 divided by 6 போட்டு ஃபஸ்ட்டு கண்டுபிடிச்சோம், அதே தான் s. So the s is 0.42 plus c value just now we found out in terms of q. So r is substituted as q, so that c is equal to 0.022 q. Substitute that q here. Okay, substitute then q here, qu by 2. So we have left side also qu, right side also qu. When you resolve it, you'll get qu is equal to 935.3 kilonewton. Now what is allowable load? Divide by factor of safety. For Hiley's formula, we use the factor of safety 4. So you'll get 233.8 kilonewton.